Today we're going to talk about Kubernetes. First, and entire class today, we will talk about how we can use Terraform to deploy a Kubernetes cluster. And by the end of this by the end of this class, you'll be able to create your own Kubernetes clusters. And even though we don't touch Kubernetes too much in this class, you'll have a solid foundation to continue practicing with Kubernetes, deploying to Kubernetes, because first problem that people have, first thing that scares people away is that not everyone knows how to easily provision a Kubernetes cluster, a Kubernetes environment to play around with. I will share my screen and we will start. So what is Kubernetes, first of all? Kubernetes is a container orchestration tool. So container is a small package that runs isolated on a server using a special thing called container runtime or container engine. The best example is Docker. Have everyone heard about Docker containers?
Yes.
Okay, very good. Yeah. So today we will not focus too much on the containers, but rather than cluster itself. But that's okay, as long as we just understand like overall what is container. It will be clear and easy to follow. And let me go to the code. I will keep our WordPress project separately and create complete separate Terraform directory for creating our Kubernetes cluster. Okay, simple as usual. We've done this millions of times already. We just declare provider and tell it which region it will use. And yeah, let's start. So the resource for that is called AWS EKS. Actually, no, well, not too fast. First, we will, of course, deploy a VPC. And the fastest and easiest way to deploy a VPC is just to have it from the open source module. Same thing we did previously, just a couple of lines, 20 lines, and we have a VPC. Nothing like too extremely complicated. CIDR blocks, CIDR file subnets, our AZs. We're not even using data source here just to simplify things. IP, we don't even need these two. And a couple of tags. So yeah, this one will remove. It will require the stack Kubernetes IO cluster and cluster name equals shared, so that Kubernetes can put its resources and create like things like load balancers for us and so on. And let's declare our local variable, the cluster name, the one that is used here, and call it EKS. Let's have it with dash, EKS-Terraform. And what is EKS? EKS stands for Elastic Kubernetes Service. Elastic Kubernetes Service, similar to any other managed Kubernetes services, made a revolution in container orchestration and made Kubernetes de facto standard of running container workloads. Why is that? Because the biggest challenge at early days of Kubernetes was how to maintain a cluster. You had to create multiple nodes, some of them control planes, some of them are workers. You had to maintain distributed key value database that stores information about Kubernetes. You had to maintain quorum, backups, reliability, all these pain of running your own Kubernetes cluster. So what AWS did, similar to what we have, for example, for RDS, they said, okay, we will take away the control plane from you and you will consume it as a service. You don't have to maintain control plane. You only connect your nodes to it and run your Kubernetes workloads, run your containers there. And that simplified things significantly. And here is where it happened like maybe 4 years ago, or around like 5 years ago. Everyone started to adopt Kubernetes because there is no longer this complexity and features and power of Kubernetes still remain. So nowadays, if you're running Kubernetes in cloud, 99% of cases will be managed Kubernetes. In Amazon, it is Amazon Elastic Kubernetes Service, EKS. In Google, it's GKE, Google Kubernetes Engine. And in Asia, it's Asia Kubernetes Service, AKS. And let's create a cluster that will live in this VPC. It will need an IAM role. I will leave it blank for now. So Kubernetes client, kubectl, is secure enough by default. So it is safe to connect to public Kubernetes clusters. However, in production scenario, it's better to have Kubernetes endpoint as private, or at least limit public CIDR ranges. So again, just to reiterate, these two options mean this option tells us who will kubectl, Kubernetes client, be able to connect to this cluster publicly or only from within private VPC? And this option says from which CIDR ranges we are allowed to connect to. So similar to similar to how SSH is working. Yeah, when we had SSH, we were opening port 22 for these ranges. Similar here. Just to simplify again, I'll put zeros here, means open internet, but in your case, I'd rather suggest that you parameterize this a little. And yeah, let's create an IAM role. And now knowledge test, how good you were listening previous lectures, especially a lecture about IAM. and IAM roles. What does this assume role policy mean? Yes.
So the effect is allow. So it's gonna allow the service EKS to do STS. I don't know what STS is.
Yes. Very good. Exactly. So it's not IAM policy. It is assume role policy, right? And remember the difference. IAM policy dictates what actions are allowed, and assume role policy says who can use this role. And what we need to do is create this role and give EKS, like AWS service, permissions to use it, so it can create a cluster for us. Very good. And we will assign a couple of policies. It will need several managed policies. There is a policy called EKS cluster policy. It's maintained by AWS. I will just attach them. And also VPC policy. And use this role in our cluster definition. Let's run Terraform apply. This will take probably something like maybe 10 or 15 minutes. And in order to save time, in the meantime, while it is applying, I will configure the rest of things, so we can use our time slightly more effectively.
Sorry, Vladimir. I have this question. What is the usage of Kubernetes Endpoint? Is it like how the public access the containers inside the cluster?
Kubernetes Endpoint is very similar to database endpoint when you, for example, use it with RDS. You need some entry points that your client can use to connect to the database, right? So in case of MySQL, it will be -- host and the host name of your RDS database, right? Kubernetes acts in a similar way. It exposes you a URL, and there is a client that you can use to connect to this URL and interact with this API that will allow you to create pods, deployments, and other Kubernetes things.
Oh, okay, I get it. Thank you.
And as usual, I make silly mistakes. Yeah, so let it run. And what we also need to do is, in case of EKS, by default, we still have to have some EC2 instances that act as a workers. So there is control plane and there are workers. Workers mean actual nodes that run actual workloads and run actual containers, while control plane is a part that hosts components of the cluster itself. So we don't manage control plane, as I described earlier, but we need to manage nodes. And for this, there is also very interesting thing called node group. Node group basically equal to an autoscaling in AWS. So in fact, when you create a managed node group, it will, under the hood on behalf, create an autoscaling group for you that you can use. It will also require an IAM role, but with different set of permissions. And we will put it into the private subnet. And the role itself. So this time, Fume policy allows it to be used with EC2. So it's just a regular IAM role that we can attach to our instances. And also a couple of policies. This is node policy, CNI policy, and container registry policy. Basically, some system level things for Kubernetes. There is no point in like explaining in details what it is exactly. Yes.
You're really interested in CNI policy?
Please repeat.
CNI policy. I'm interested in knowing what it is exactly.
CNI. Okay. So CNI called Container Network Interface. This means basically Container Network Interface in Kubernetes is an extension, is a program that runs on the cluster and controls how internal Kubernetes workloads like pods, deployments, services, everything that runs on Kubernetes and use networking interact with the network on the host. There are different CNIs like Leaf, Calico, Flannel, and so on. And Amazon has its own CNI called AWS VPC CNI. And in order for this CNI to work, we need this CNI policy to be attached to the node that's under our Kubernetes cluster.
Okay, thank you.
Okay, and also we need to create a couple of security groups. Actually, one security group and attach it to our node, which will allow it to talk with the control plane. And here is the interesting thing. It is not assigned to anything. It is basically how it is assigned to our nodes is through this tag. Kubernetes, once it started, will discover that there is a security group and use it to when provisioning our worker nodes. And also we will add some depends on statements, so it deploys in a correct order. And let's apply. No, it is still creating. Yeah, Kubernetes cluster, EKS cluster is also very long. Takes long time to be provisioned, like probably like 15 minutes. So we have 9 or even 10 minutes more to sit and wait. And yeah, if you have any additional questions, yeah, that's the perfect time to discuss.
Can we use this time to explain the structure of Kubernetes, like the relation between the API and the workers in a diagram to simplify it?
Yeah, in a diagram. Yeah, let me try this. But you know, Kubernetes is so complicated topic. So obviously there will be a separate course dedicated exclusively to Kubernetes, and I've decided to break up the structure of the program a little and have Kubernetes kind of as a separate wave, as a completely separate set of classes. But don't need to worry, all you guys are automatically invited there. And as soon as it's ready, I will share it with you for sure and invite you. But for now, of course, let's talk a little about Kubernetes plane and all its components. Okay, very cool. So, first thing first, as I discussed again second ago, not second, like 10 or 20 minutes ago, Kubernetes consists of like two high-level components. It is control plane and data plane, or also worker nodes, it is called. Control plane is the engine of Kubernetes cluster. Control plane is something that makes the cluster running. And data plane or node group or worker nodes is something that runs the actual workloads. Now, the best way to explain Kubernetes components is that to walk through the process of what is happening under the hood when Kubernetes when we want to run a container on a Kubernetes. Yeah, to run a container on a Kubernetes, we will create a thing called pod. And what will happen? So we always, like, the entry point and the main gate for interacting with Kubernetes is API server. So API server is the thing that exposes this API, this endpoint that not only we as a user and as a client can interact with, but other components also. Almost all communications within Kubernetes between different components happen through API server. After that, API server will put some information about the resource that we're creating into etcd. etcd is an open source distributed key value store, like a database. It's a database, it's a memory of Kubernetes. It's a database that stores the information about what's running currently in our cluster. Then API server will go to scheduler, and this component is responsible for choosing the proper node. So you might have multiple nodes. Most likely, if that's not your home lab, this will be more than one node, and they will have different characteristics, different sizes, different types. Some will have more loads, some will have smaller nodes. So scheduler will review all this information take into account additional rules that we set in order to like about how we could place how each should place components. Like, for example, you should never run these two containers on the same node, or vice versa. Always run them together, or never run this type of container on this type of node, and so on and so forth. So scheduler will choose which node the container should run on, and indirectly notify kubelet. And it is interesting thing how it notifies kubelet. As I mentioned, they don't talk together directly with each other, right? Scheduler will change the information doing this through API server in the etcd database about on which node the pod should go. And what kubelet is doing is that it is sitting on each node and constantly asking API server if there are no containers if there are new containers that it should run. And if yes, kubelet will pull it and run the container. Also, there are additional components like kubeproxy. Kubeproxy is something that's in charge of setting up networking rules. The CNI driver that we've talked about interacts with kubeproxy a lot. And two more components is controller manager and cloud controller manager. So in Kubernetes, almost everything is a controller. Controller. To explain what is controller, the best what we can do is use a standard definition from like traditional real engineering, from industrial things. So controller is an automatic loop that checks current state of the system, compares it with the desired state of the system, and if they differ from each other, they make proper adjustments. So if you were to have like controller for a door, right, and set it to close, if someone opens this door, controller will discover this and adjust the door, basically close it back. Same here. Any object inside Kubernetes, there are a lot of different ones. If something is, or somebody or changes its state, makes edits to it, controller will pick up and return it back. And separate type of controller manager is cloud controller manager, is controllers that is specifically responsible for for managing cloud controllers that manage cloud objects for you. So, and in the next session, next Tuesday, I will demonstrate this to you. In Kubernetes, you can, when you run it on cloud, you can heavily interact with different cloud objects. Like, for example, you can create load balancers directly from Kubernetes. Or, for example, you can integrate Kubernetes role-based access policies with IAM of AWS. Or you can provision hard drives in AWS and whatever you want to. And these things all done using cloud controllers, which are under Cloud Controller Manager umbrella. In fact, these both Controller Manager and Cloud Controller Manager themselves are controllers that manage other types of controllers in Kubernetes. It's very, very high level. It's, again, okay if you don't grasp it from the first time, no worries. And there is definitely opportunity to dive deeper into it. But this will be done later.
Thank you.
Okay, cool. We've created our Kubernetes cluster, and now let's apply one more time. But as we remember, while we were creating these, we've added additional node groups. Let's run Terraform apply again. After I fix my stupid misprints and also add node IRM. I am roll. Yes.
Question about tags. The tags are annotations, are considered as annotations to Kubernetes or not?
This one?
Yeah.
No, that's different objects. Annotation is barely a Kubernetes API thing, but these tags, it looks kind of similar, and structure is very similar to annotation, but that's not annotation, that's a tag.
Okay.
But overall, yeah, interesting thing. Yeah, this tag serves as an annotation, but it's still a tag in AWS. But yeah, the idea of annotation is that some external thing, some like controller in case of Kubernetes, goes and checks this object, check its annotation, and looks for annotation specific to this controller and saying something like, "Oh, I see this annotation. Perhaps I need to do something." Right, and this acts like additional implicit commands that we give to Kubernetes to properly control the objects and how they're handled by other things. And similar situation here, by using this security, this tag for our security group, we kind of annotating it so that Kubernetes can find it and use it when creating our EKS node group. So probably, like, I think the precise answer will be like yes and no.
Okay. Thank you.
Yes.
If we have a managed control plane, can we have an etcd database, an external etcd database or no?
We can have our own etcd database, but when we create our own Kubernetes cluster without using EKS. And you don't want to go this route. That's an overkill for the majority of cases. Yeah, but yeah, if you run Kubernetes like in your data center, you have no choice. But otherwise, I will always advocate and rather suggest use managed Kubernetes. Okay, we have it completed. So let's see what we have. Here's our cluster. When I run these AWS EKS list clusters. Also, I will, just a second, let me open AWS portal and show you our cluster there. Give me just a moment. We go to EKS, Elastic Kubernetes Service. Here it is. Here's our cluster. We can go to compute and see that we have a couple of nodes assigned to it. And there is a command called AWS EKS update kubeconfig. What it does is, let me clean my present kubeconfig first. I will demonstrate the kubeconfig itself to you. So this one, for example, server, right? That's the exact endpoint our kubectl will talk with. this is where we're sending our requests. We can even use curl, for example, and send like regular web requests to interact with it. This one, certificate authority data, is basically our secret that we use to authenticate with Kubernetes. And some additional extensions, since it's managed Kubernetes. There is slightly different like mechanism of authentication, but this kubeconfig will work perfectly well for us. And when we run kubectl get nodes, it will give a list of nodes. And for example, we can say kubectl run nginx image nginx replicas equals 3. So what it will do is it will create an nginx deployment, use container image nginx, and it run it in 3 replicas. There will be 3 containers running. And when no, hold on a second. It's a pod. Sorry. Yeah, slight mistake. Let me delete it. Okay, so 1 second. Yeah, now it's much better. Let me show it again. So by doing these commands, kubectl create deployment and kubectl scale deployment, I created like kind of, how to better explain it. It's like an additional layer of abstraction. So previously we had physical servers. In cloud, we started to operate using virtual servers. And now we have containers and pods and deployments operating inside our virtual servers. And correlation between a deployment and a pod is that deployment is like an AutoScaling group, but for pods in Kubernetes. And pod is like a regular instance. And the thing called service corresponds to the load balancer. In fact, there are actually different types of services, but again, not today. Sometimes later I will explain in more details. But when we chose the type of service load balancer, it will go through the controller manager, through Cloud Controller Manager, to interact with AWS API and provision this load balancer for us. That we can open it in our AWS console. Let's see. Let's check it. Here it is. So all these load balancer, this security group was created not by Terraform, not by me, but by Kubernetes. This one. Let me see. Inbound rules, HTTP from everywhere. Yeah, we can then now open it. Copy DNS name, HTTP. Welcome to Nginx. Nginx that is running on inside our Kubernetes cluster. And yeah, that's like we are kind of like now we're kind of opening the entire world of Kubernetes. There's just a starting point and more to come, much more interesting things. Next time, I will demonstrate you some more things about how could we run Kubernetes and how could we use Kubernetes. And yeah, and probably after that, there will be a final project to make some intermediate milestone and conclusion about this. But let me delete everything 1 second. So your task for today will be to create your own AWS EKS cluster. And similar to how we did before, how we did today, you can use open source module for your VPC. And there will be also open source module for EKS. But I strongly encourage you first to try it creating yourself, assembling it from resources. So later when you use open source modules for EKS as well, you will understand what's inside, and you'll be able to find out in case something goes wrong, to troubleshoot, or even maybe to contribute back when you have some improvements or new things that you would like to bring back to the community. Okay. I know today it was a little, I would say, maybe too much information. Hopefully I did not overwhelm you guys. And do you have questions?
Well, actually, I don't have experience with Kubernetes or any knowledge, so I'm kind of finding it like complicated. But
yeah, I understand.
I hope it will be easier in the next session.
So at this time, the acceptance criteria and success criteria for completing these I would say home task and practical task is just to have Kubernetes and connect to it using kubectl. You can run kubectl get nodes, for example, or any command from this Kubernetes cheat sheet. 1 second. kubectl cheat sheet. It gives you like tons of different examples about what commands you can run in kubectl, and once you have a cluster, it is perfectly safe to run them. Don't be afraid. You can create the cluster and experiment a little, like read more from this cheat sheet. I send it to Slack once we finished. Yeah, and Ramdan, you had a question. Yeah.
Yeah. So about the authentication to Kubernetes. So it's done through the kubeconfig, but kubeconfig is how is it, like all the certificates and the information is done by the cloud controller, or how is it done?
No, API server. It connects to API server, and API server is doing this authentication.
And these certificates are created by which component?
Oh, good question. I honestly don't remember, but you can check and find out it in documentation if you'd like.
Okay, thank you.
Okay, then if there are no other questions, talk to you next Tuesday at 3 p.m. US Eastern Time. and have a good rest of your day. And yeah, talk to you later.
Thank you.
Thank you. This
Bye-bye.
one.
Bye bye.